You know, every single day we throw stuff away. We don't really think about it. But behind that simple act, there's this enormous hidden problem. It costs billions of dollars, and it's a huge source of pollution. We're going to take a look at how a surprisingly simple bit of math could completely change the game.
It's a sight we all know, right? The garbage truck comes down the street, picks up the bin, and suddenly our trash problem just disappears. It's just a basic part of how our cities work.
But here's the question a team of researchers decided to ask. In this huge, complicated network of trucks and landfills, are we actually moving all that trash smartly? Turns out the difference between just moving it and moving it smartly is, well, it's massive.
And the answer to that question is a big, fat no. We're not being smart about it at all. It turns out that by just rethinking the paths our garbage trucks take, we can save an incredible amount of money and do a whole lot of good for the environment. So let's dig into how they figured this all out.
Okay, first, before we get to the solution, we've really got to understand just how big the problem is. The researchers zoomed in on one case study in Brazil that shows you exactly how inefficient the way we do things right now can be.
So if you look at this state in Brazil, the issue becomes super clear. You've got all these towns sending their garbage to different landfills, but the whole thing is just a chaotic mess. Trucks are literally crisscrossing each other, taking these super long, illogical routes and just burning insane amounts of fuel.
And the numbers here are pretty staggering. Get this. Every single day, the garbage trucks in just this one state travel almost 53,000 kilometers. To give you some perspective, that's like driving around the entire planet Earth every single day.
And all that driving costs a ton of money. We're talking nearly $44,000 spent on fuel alone each and every day. That balloons to over $16 million a year, just for gas.
And of course, there's the environmental cost, which is just as bad. This whole inefficient mess pumps out more than 34,000 tons of CO2 into the air every single year. It's like this hidden pollution tax we're paying for disorganized trash routes.
So, okay, the system is broken. It costs too much, it pollutes, it's just plain inefficient. How in the world do you even start to fix a problem that big? Well, as it turns out, the answer is math, specifically mathematical modeling. The researchers had this really clear four-step game plan. First, they just gathered all the data they could find. Population, how much waste people produce, where the landfills are, road maps, you name it. Then they calculated the real transportation costs, getting so detailed they even looked at how the slope of a road affects fuel use. Next, they plugged all of that into a powerful mathematical model. And finally, the model worked its magic and spit out the absolute best plan.
Now, the big idea behind this whole solution is something called inter-municipal consortia. I know, it sounds super complicated, but the idea is actually really simple. It just means groups of towns and cities agree to share one landfill. The trick, the real magic, is using math to figure out the absolute smartest way to create those groups.
So what happens when you take this model and just apply it to the system we have right now, using the landfills that are already there? Well, the results of just reorganizing things are, honestly, they're pretty mind-blowing. And this, right here, this is the craziest part about fixing the current system. To get these huge savings, they don't need to build a single new thing. Not one new landfill, not one new truck. All it takes is an administrative change, just a smarter plan for who sends their trash where. That's it.
And here's what that change actually looks like. Before, you've got these sprawling all-over-the-place routes. The longest trip one truck has to make is an insane 527 kilometers. But after you optimize it, you get these neat, tight, logical clusters. And that longest trip gets slashed down to just 170 kilometers. That's a huge difference.
So what does that mean for the bottom line? Well, it means the annual fuel bill just plummets. It goes from $16 million a year all the way down to $7 million. That's a saving of over $10 million every single year in fuel and maintenance, just by changing the routes.
But the researchers didn't just stop there. I mean, saving money today is great, but the real power of a model like this is its ability to help us plan for the future. So, what happens when we look ahead a decade or so?
So the future has this kind of double whammy of a challenge. First, as populations and economies grow, we're going to be making about 26% more trash. And second, at the same time, most of the landfills we use now are going to be full. They're going to close down. So we're looking at more trash and fewer places to put it. And this is where the model goes from just being an optimizer to basically being a crystal ball. It doesn't just guess where we should build new landfills. No, it calculates the exact, optimal number and location for them, 37 new sites, to create the most efficient network imaginable for the future.
And just look at this comparison. Now remember, this future scenario has 26% more waste, but even with all that extra trash, the new optimized system cuts the daily mileage and the CO2 emissions by about 60%. And the fuel cost? Wow, that drops from $16 million a year to just $3.3 million. That is an almost 80% reduction in what they're spending. It's incredible.
So, let's zoom out. What does this all really mean in the grand scheme of things? Because this study isn't really just about one state in Brazil, it's a blueprint. It's a model that any city, any region, any country can copy to build better, cheaper, and cleaner public services using data.
So if you're going to take away a few key things, here they are. The immediate savings are massive. You can cut fuel costs by more than half right now. The long-term savings are even bigger, more than $13 million a year. The environmental impact is huge, and maybe most importantly, this isn't some one-time thing. It's a method that could work pretty much anywhere.
And to put that environmental benefit into a perspective we can all picture, the total CO2 saved over the 20-year lifespan of this new system would be 411,000 tons. That's the same positive impact as preserving over 7 million square meters of tropical forest. It's a way to see how the math connects directly to a real positive outcome for the planet.
And the final number? The ultimate payoff? Over the life of this new, smarter system, the total projected savings in just fuel and maintenance costs is more than $250 million, all from applying a little bit of math to an everyday problem.
Which leaves us with this really cool question. We've just seen how data and some smart modeling can totally transform something as boring as trash collection. So what's next? Public transit? Emergency services like ambulances and fire trucks? How we distribute water? The potential for using data to build smarter, cheaper, better cities, it feels truly endless.